Okay, guys, welcome to today's lesson in statics. Today we're covering problem number 36 from chapter 4. So number 36 says, a light bar AD is suspended from a cable BE and supports a 50-pound block at C. The ends A and D of the bar are in contact with frictionless vertical walls. Determine the tension in cable BE in a reaction to A and D. So I've gone ahead and drawn the free body diagram. I've listed the given dimensions as well as the weight applied going down 50 pounds. Now, knowing this bar is in equilibrium, we can go ahead and write out our equations for equilibrium, knowing, say, for instance, sum of forces in the y direction is equal to 0. Now, this tells us if the sum of forces in the y direction are equal to 0, then we would have tension B to E going up, so positive tension scalar value tension B to E, and we have only one other force acting in the y direction. We have a 50-pound force acting straight down, so minus 50-pound force in the j direction going straight down, and that is equal to 0. So we would add 50 pounds to the other side of the equation, and this tells us the tension value in cable BE is equal to 50 pounds of force. So just like that, we already have solved for the tension in cable BE, knowing the tension is vertical going up, and that's counteracted by the 50-pound weight going down here. Next, we can go ahead and write our next equilibrium equation for some of the moments. Now, I'm going to pick moment about point A being equal to 0. We know it's equilibrium, it must be equal to 0. This tells us that if moment about A is equal to 0, then the moments of these forces added up about point A must equal 0. So we have this force tension B to E, we know is equal to 50 pounds. This is creating a counterclockwise moment about A. The perpendicular distance from point A to point B is 5 inches, where the force is being applied. So the moment would simply be 50 pounds multiplied by 5 inches. Then we're going to have another moment at point C, where the weight is acting pulling down. This is creating a clockwise moment about A. The perpendicular distance would be 5 plus 3, or 8 inches, and the force is 50 pounds. So we have minus 50 pounds multiplied by 8 inches away from point A. And finally, we have our reaction at D, which must be horizontal because this is a frictionless wall. So we have a reaction A pointing to the right, reaction D pointing to the left. Due to being a frictionless wall, these have one component for the forces. Our reaction at D is creating a counterclockwise moment. We're to extend the force of application, extend the force where it's applied to right here. We would see that it's being acting in a counterclockwise moment about A. So we have the force at D, reaction at D, multiplied by its perpendicular distance to point A, which is 8 inches. So we have plus counterclockwise moment D times 8. And this must be equal to 0. So let's multiply this out. 5 times 50 would be 250. Now, 50 times 8 would be minus 400. Plus 8D equals 0. 250 minus 400 is negative 150. Plus 8D equals 0. Then we can move the 150 over, add 150 both sides. We get 8D, 8 times the reaction force D is equal to 150 pounds. And we'll use our calculator for this last step. 150 divided by 8 is going to be 18.75. So our force for D is 18.75 pounds of force. Now, because this is positive, it means the direction we have drawn the arrow, the vector D, is correct. If this was a negative value, we would reverse the direction of the vector for D. So I'm going to include an arrow going to the left for vector D in my answer. It is a vector going to the left. Finally, we can write one last, solve for our third unknown. We can write one last equilibrium equation knowing sum of force in the x direction is equal to 0. This tells us A, which would be a positive value going to the right, the positive x-axis direction, minus d must be equal to 0. We know this because there are no other x forces acting in the x direction. Now we know the value for d we just determined was 18.75 pounds of force. So A minus D, or A minus 18.75 pounds of force, is equal to 0. So A must be equal to positive 18.75 pounds of force. A positive value simply tells us the direction in which the vector A is drawn in is correct. A is acting to the right, D is acting to the left. So this would be, you include this direction symbol as part of our answer for the vector in point A. We have the reaction at point A, the reaction at point D, and the tension in cable BE all solved for.
Alright guys, thanks for joining me in another simple STEM solution video. Be sure to like and subscribe. Also, if you'd like to support this channel or have particular questions you want answered, be sure to check out my Patreon community via the link in the description below.